Hey guys, welcome to the channel, and in this video I will be explaining you a concept of binary search using non-recursive method. So in the earlier video I have showed you how to solve this concept of binary search and search an element using the recursive method. So if you haven't watched that video, I will put the link somewhere in the above, so you can go to that playlist or in that video and you will see the explanation of how binary search works. So in this video, I will show you the non-recursive method of doing this binary search. So I will not go into deep details of what binary search is and how it works. So simply I will just start with the non-recursive method of solving this. So we will call this non-recursive binary search function from the main, and we have passed the argument, that is the start index and the end index of our array. So you keep in mind that if you have not given an array in the sorted order, then you have to sort it first, because binary search works on the sorted array only. After that, we have passed 0th, that is of our start index, and the 7th, that is the end index. And this function, when we call, it will return the index. So we have write the integer as its return argument, so it will return the index at where we have found out our element. So in the main function, what we write is we have to make this loop run until start is less than end. Okay, so this is the termination condition for our this iteration or loop. So start is our initially at 0 and end is 7. So in the recursive method, I have showed you that for each iteration we have to find the middle element, and we will find the middle element using the formula of start plus end minus start by 2. So this is the formula I have used to find the middle element. Once I found out the middle element, we need to update our start and end according to the middle element. So we will check that if the array or the value present at this middle element is equal to the k which we need to find. If this is the case, then we will simply return the mid element index. Else, if we need to check that if the value present at this middle element is greater than k or not. So if it is greater than k, that means, let's say our middle element is set index 3 and this value is either less than or greater than the 7. Suppose if we want to find the element 5, let's say, just in case. So we will find out that the value present at this middle index 7, that is greater than this 5. So we need to explore the left part, because there is no way we found out the element 5 in the right part. So this part is ignored. So in this case, we need to update our end variable or end index, which is initially at this location, to this location. So therefore in this case, we will update our end with mid minus 1. Else, if it is not the case that the value present at the middle index is greater than k, then we will need to update our start, which is initially at here, to this location after the mid. That means else we need to update our start with mid plus 1. So this is the simple function which we have to solve the problem of this binary search and search any element. So now let's see the time and space complexity in this case. So if you have seen this, what we are doing is we are recursively calling this function and calling this while loop, and in each iteration of this while loop we are narrowing down our search to half. Either we are moving our end or we are moving our start. So let's say if we have this value 10, then in the second part we have to explore the value 5, in the third part we have to explore value 2, in the fourth part we have to explore value 1, and so on. So effective time complexity in this case is O of log n, and the space complexity is in this case is O of 1, which is constant. But in the case of recursive method of solving this, that is taking O of log n space complexity. If you haven't watched that video, watch that video. I will explain there that how it takes O of log n space. So now let's quickly see how to code this. What we have called the function binary search non-recursive. In that we have passed the array in the form of the vector, start index, end index, and the value which we need to find, that is we need to find in this case 10. Okay, so we will iterate our loop, this while loop, and we will check that while start is less than equal to end. So let me clear it out, that this is start is less than equal to k. Until start is less than equal to k, then we need to follow this iteration. Okay, so while start is less than equal to end, we need to update our mid, or first we need to find our mid. Then if that value percentage is mid is equal to k, then we will simply return the mid from here. Else we need to update either end or start according to the value present at the mid. So this I have explained you how to update this. And if this, after this while loop, if the while loops terminate, then we will simply return -1. This represents that we did not found any element. Okay, so if we try to run this code, so it compiled successfully, and after that when we run it, it will show that found at index using non-recursive. So we found out that our value is present at index 4. So hope you got this question. If you find any difficulty in understanding the first part of this question, then you can see the recursive method solving of this binary search. So in that I have explained you the detailed way to solve this. Okay, thank you.